Okay, so a warm welcome everyone to our lunchtime learning sessions. We've been covering topics over the past few months around sharing skills around adaptation, climate adaptation. So today we'll be hearing from our expert speakers, sharing knowledge with us, and also giving a Forth Valley context for some of the solutions that we'll cover. As ever, please do keep an eye on our Eventbrite page and sign up to our free membership in order to keep up to date with our next events. We've got myself here from FEL and also Isabella, who I think is hopped on and will be back on as well. So we're here to help with anything in the chat if you have any questions at all. These lunchtime learning sessions feed into a larger piece of work as Forth Valley's Climate Action Hub, which is to raise awareness of climate actions that can be realised in our area and amplifying some of the fantastic work that's already being achieved. Today we'll hear from three key speakers around retrofitting. We've got Tom from Local Homes, David Sutchfield, who's a local, and Claire from Hoose Limited. So what we usually do with these sessions is hear from all of our speakers first, and then hopefully have some time for Q&A discussions afterwards. Today is quite jam-packed, so in case we run out of time, please do feel free to pop things in the chat, and we'll make sure that we follow up with some answers for you, just in case we run out of time. So if that sounds okay for everyone, I think I was going to move on to our first speaker, which is Tom from Local Homes. Tom, if you're happy to take us away.
Yep, very happy. Could you hear me
Thank you.
fine?
Yep,
Yep, okay, and that should be sharing my holding slide.
it is, yes.
Yeah, well, thanks so much, FEL, for the opportunity and everyone for turning up. I'm going to be talking about a couple of resources that we've created, commissioned, about adapting our homes. So, it's my slides. So yeah, a bit about me. I'm Tom, and I put a picture of the Opera House there in Sydney because that's where I'm from. I'm Australian. You will have heard that in my voice already. Um, and since about 2013, I've made it really my work to contribute towards ensuring we have a fast and fair transition to clean energy, decarbonising our economy. And mostly that means I've been working in the community energy sector. I'm co-founder of Local Home Retrofit in Glasgow. And what I really wanted to do was to create a local organization in this new place that I call my home, Glasgow, that was responding to the needs of local people in reducing carbon emissions coming from their homes. So you look in various places around Scotland, and you often come up with this sort of a statistic that somewhere in the range of 1/3 of our carbon emissions comes from our homes, and the vast majority of that is from heating our homes. So if we're going to tackle climate change, we need to address the fact that so much comes from our homes. And in addition to that, we also have homes that are not in a great state in terms of being poorly maintained, inefficient, not necessarily very comfortable or healthy, and I think most people will agree that they're fairly expensive to heat. And we also know that compared to our neighbours, our European neighbours, our housing stock is quite poor, and the thermal performance of our housing is quite poor. And because the vast majority of homes that will exist in the future have already been built today, we know that we can't demolish and new build our way out of this. The only option really is to retrofit our existing building stock while making sure that we're building new homes that are low carbon and energy efficient. In other words, the only option we have is to retrofit. So retrofit is a combination of two words, means to retrospectively fit, and you might retrofit a ship, bring it into dock and bring it up to date. perhaps it's a military vessel, but we're not talking about ships, we're talking about homes. And so for today's discussion, we're saying that retrofit is fitting new energy efficiency measures and renewable heating into an existing building. And the three dimensions that we like to talk about is low carbon heating, which in almost all cases means installing a heat pump, insulation, and ventilation. And the great news is that when you do this, you bring a whole lot of benefits, improving the issues that I mentioned a few slides ago. So it's going to be a more comfortable home, a healthier indoor environment, lower environmental impact, and lowering your bills, almost certainly. The problem is that retrofit is expensive, complicated, risky, and it's just generally a really difficult process. And that's why Loco Home exists. That's what we set up to do. And our mission is to make better retrofit more accessible to more people with a strong focus on locally in Glasgow. And we're a climate change organisation. Our primary purpose is to address that 34% of carbon emissions that comes from our homes. And the way we view it is that, it's definitely warming. It's definitely us. We're absolutely sure about it. And the situation isn't great, but there's definitely things that we can and should be doing. And in light of that, I think that really you've got a choice as an individual or a household to do nothing about the fact of climate change or do something. And importantly, that if you don't engage with this and you make no decision, you don't do any planning, you are doing nothing. So it's important that people understand that climate change is something we should respond to, and that they really should be making plans for. And in technical climate jargon speak, there's basically two things we can do. We can reduce our carbon emissions, mitigate, or prepare for the more severe impacts that are being predicted, so adapt. And I'm talking today about adapting our homes. So we've been really fortunate to have received 2 rounds of funding through the Climate Engagement Fund from the Scottish Government. And it was on the second round that we undertook this adapting our homes to the impacts of climate change work. And we did two things, or we commissioned 2 experts. One is we recruited a climate paleontologist who lives in Glasgow, actually Paisley, Ben Richards, and he's a communicator. And we got him to look at what is the climate science telling us is likely to be the impact of a changing climate on a place like Glasgow or this part of Scotland. And then we also brought in John Gilbert Architects, in particular Chris Morgan, who's been thinking about adapting our homes for a long time, to say, in light of those changes that are being predicted, what are the things that we can do to adapt our homes? And out of that, we have this report that's on the screen at the moment, so you can download that. We also have a webinar that Chris Morgan gave. And I think in that it's about 35 to 40 minutes of actual presentation time. So he's going into a bit more detail than I'll be covering today, without doing a direct walkthrough of his report. So I recommend that the minimum you should do is download that report, but if you want a more digestible form, then have a look at Chris's webinar. And also Ben Richards, the climate communicator, there's a really nice video. It's just a 10-minute discussion with him created by a professional filmmaker. So it's very nice and easy to watch. And I should also say that if you do look at these links on our YouTube page, go and have a look at some of the other videos, because using the first round of climate engagement funding, we created a series of videos about retrofit. And some of those include things like the flooding impacts that we're starting to see already in our homes. And the gist of what the findings were in terms of Ben's work is that while there is a lot of uncertainty, what we can be quite sure about is that things are going to get warmer generally, and especially in summer. They're going to get wetter generally, and especially winter. And they're going to be wilder. There's going to be more extremes, stronger winds, bigger storms, heavier rain, more potentially drought. And we've drawn from various resources to come to these conclusions, including information from Adaptation Scotland, the Committee on Climate Change, and meteorological data. So I'm going to run through for the next maybe 5 to 10 minutes. So I'm not going to be taking up, I'm definitely not going to be running over on my time today. I know that's not even an option. But I'm just going to be running through that structure: warmer, wetter, wilder. And these slides are a bit of a repeat of the content that's in that document, and it's a bit of a repeat of the material that Chris Morgan presents in his webinar. I'm not trying to repeat what Chris is doing in his webinar. I'm merely trying to introduce this resource so that people understand what it covers and why it's so valuable. I should say that I'm not a building expert. I'm a community social entrepreneur, and anything that I'm saying today should not be taken as advice on what to do for your specific home. This is just general in its nature, and I'll refer you back to the original report. So what's going to happen, somewhat obviously, is that with climate change, with global warming, things are on average going to get warmer. So all the evidence is that we're very unlikely to remain to 1.5 degrees. Some people are saying maybe we've already exceeded 1.5 degrees. And that's going to have certain key impacts. So there's 10 points across the guide. So 4 of them here in this warmer section. So we're much more likely to experience overheating in our homes. And while that might not sound like a particularly serious issue, the point made in the guide is that the factors that contribute to heating does include the climate in which you live in. But that is not as important as the design of the building that you're in. And that in turn is not as important as the occupancy or the behaviors of the people within those buildings. And the point of that is to say that we will definitely experience overheating inside buildings in Scotland, and probably experience it as badly as anywhere else, because our buildings are not in a great state, and because there's not a general awareness of how we can deal with overheating, because it's not something that we're used to. And the impacts can be very serious, particularly for vulnerable people, particularly for young and elderly and people with other vulnerabilities. We're more likely to experience urban heat island effects. We're more likely to experience fire risks. And that's simply because there's going to be more likelihood of there being dry, burnable materials in the environment, which can cause runaway fires. For example, a couple of years ago, we had significant heat waves in London, and there was big, in the south of England, I should say, and there were significant fires affecting multiple houses where the fire just ran from house to house. And then finally, we're going to have thermal stress in buildings. And that ranges from things like materials that can't handle these higher temperatures, particularly think of like flat roofs with felt or tar materials, which could melt, but also expansion and contraction of those materials, which if it's not designed properly, could cause damage to buildings. And then what the guide does after talking about each one of those points in some degree of detail, is it then provides these cartoony like drawings, which Chris has created, to talk about what a typical home might look like, typical house might look like before and after making the adaptations. And the point here is that the majority of these are actually quite easy to achieve. Most of them can be done without significant disruption or expense. So for example, to counteract overheating, we need to avoid situations where we don't have shading, that we don't have a lack of ventilation in our homes. A well-insulated home is also going to protect us from the heat coming in. We need to make sure that we're avoiding situations where there's no shade, introducing heat unnecessarily into the house through things like long duration oven cooking, and looking at the materials of our buildings to make sure they're up to increased temperature extremes, and making sure that in our broader urban environments we've got less hard surfaces. You can see the same house with all of these measures, all these issues dealt with, starts to look a lot different. We've got much less hard surfaces, we've got more trees, we've got better maintenance, we've got the insulation. We're putting in relatively straightforward measures like green roofs, and we've got water buffers and water storages in the environment. In terms of wetter, what we know is that a wetter and warmer environment means that we have more plant growth, and that can cause issues, particularly issues when we have uncontrolled plant growth growing in or near buildings. Is what we're talking about. More likely to have rain penetrating into the fabric of the building. That can happen for a variety of reasons, because rain is being driven against the surface of a building, because it's splashing onto the surface of the building, or the drainage system, rainwater goods are not up to the job. We can have increased wetting and drying cycles, which makes it even more important that we're using breathable, vapor permeable fabric in the retrofit of our buildings. In some circumstances, we need to be making significant plans for how we deal with flooding. In all circumstances, we need to think about flooding. And for some houses in certain locations, we need to be really mindful of ground movement. So things like slippage of land or worse. And so again, we've got these two diagrams, and I'll jump to the second one because it's kind of nicer to talk in a positive, but we can see we have fairly straightforward measures that we can do. A lot of this is about maintenance, making sure that we've got good access for maintenance and our homes and the surrounding environments are well maintained. So good fixing points for maintenance, good access to drains, make sure that you're maintaining your roof and your gutters to remove plant material. Make sure that your home is well ventilated, because if water is going to be getting into the building at a higher rate, it needs to be able to get rid of that moisture. The roof is absolutely critical. In some circumstances, you might need to consider new surfaces on the external of the building to protect against driving rain. We might need to think about changing some other more design features of the buildings to prevent rain from reaching the surface of the building as well. And then in terms of flooding, there's a bunch of local things that we can do. Make sure that we've got effective drainage, try and create soft surfaces that soak up the water. Planting trees is always a good idea. And there's a key point that Chris makes, is that while there's some small number of circumstances where trees can be a problem, particularly in wild weather, that's that's only a really small issue compared to all of the benefits that trees bring. We definitely want more trees in our environments. They help with a bunch of these problems. And then finally, things are going to get wilder. So things are going to become unpredictable. And a lot of things we've spoken about, we don't necessarily know when they're going to happen, but we know that when they do happen, they're more likely to be more extreme. So perhaps hard to believe, but there is increased chance that there's going to be droughts, even in Scotland, and there's things we can do to prepare for that. And we've more recently experienced some pretty serious storms. Storm Owen earlier this year, and then the storm that impacted the East Coast a year or so before that. So a lot of this again is about maintenance, but whenever we're looking at rain, like heavy rain, how can we store water for use later? Not heavy rain. When we think about rain, how can we store that for later? Perhaps people in Scotland and the UK are going to need to start thinking more like Australians think, where you need to have local storage of your water in your garden to be able to water your gardens. What are the sensible ways to use water in these environments in the case that a drought was to come along? And we just generally need to be making our homes a lot more robust. And I think the point that Chris makes is there's a lot of things that are common sense. You can walk around your house and just use your powers of observation to identify the things that are likely to be a problem in a storm event and try and resolve those before the storms arrive. So that's me. Hopefully I haven't been too horribly off the time. I will stop sharing, and I look forward to any questions that people might have at the end. Thank you.
Thanks so much, Tom. That was brilliant and some really interesting visuals there. And also to say, I totally appreciate the challenge of talking about a generalization of retrofitting in 1 hour. I think you've done very well there for your time. So next, we were going to hear from David. And sorry, I didn't mean to refer to you as a local. I meant to say a local resident of Forth Valley, David. So
Brilliant.
thank you if you're happy to take us away.
Yep. I'll just share my screen. Share that one. Share. And hopefully you should be able to see my screen now.
Yes, that's working. Thank you.
Brilliant. So I'm going to bring this down to specifics of two houses and show what Tom has been saying and how that can be applied into two houses. The top is a house that I lived in for nearly 20 years in Pittenweem, and the bottom house is my current house here in Callander, just showing the solar and the situation in the woodlands there. So looking at the first house, we are improved the building envelope. We insulated the floors, walls, and roof, and we upgraded the windows, improved the draft proofing to reduce our heat load. This was done over 20 years, and we did it piecemeal. We then changed our heating system to a combi boiler. Then we changed it to a heat pump, and that was done after we then installed triple glazing on the front of the building. So house 2 is in Callander, and we had different priorities. So first thing we did is we spent a year investigating the house. We did thermal imaging, we did an air pressure test, and we did nothing for a year. And now we've we've had a new roof, which makes us a bit more stormproof. We've installed solar PV and battery, and we are installing an air source heat pump. As I speak, we are 9 degrees centigrade in the house. I'm sitting with a little fire next to me because we've taken our boiler out and the new radiators are going in right now. I will be installing a mechanical ventilation heat recovery system, and we'll then be really improving the air tightness. Then we're going to be improving the fabric, which is a planned strategy. Just it's not the normal way around of doing it, but that's what we're going to be looking at for this house. So what do the investigations look like? The left screen shows the door sealed up with the fan test to pressurize the house to 50 pascals and then depressurize the house to 50 pascals. I then went round with a thermal imaging camera at the same time, looking at where cold air was pouring into the house, and then went round the outside when we pressurized the house to look at where hot air was pouring out. So here you can see the trickle vents showing a dark image, and then a lot of drafts around the bottom of the door for this particular patio door. And that gave us a lot of very valuable information about where the air leaks were and where the cold spots were in our house. Going back to pit and wean, we started pulling it apart. When they put the triple glazing in on the left, you can see the cavity wall insulation in the middle of the wall, and it's very partial at that point. So one of the guys putting the windows in filled all those gaps and made sure that was okay. So we had it commercially done, but this was about 15, 20 years ago. Under the floors, we went through and my wife spent several weeks under the floors, carefully fitting polystyrene up under the floors, and that made a big difference. So that's what that looked like in the solum underneath the ground floor. So we used polystyrene for that. Upstairs, we pulled all the plasterboard down and installed kingspan. So in that ceiling and a combed area, and we tape sealed all of the area, put the plasterboard back, and then replastered. So fairly invasive stuff, but it made such a huge difference. I did it after I went to a friend's house, and we stayed with a friend's house who'd done that themselves, and it was so nice to be in their house, and whereas it was cold in ours. So it stays, the house, the bedroom stays cold in summer and warm in winter. And then in the loft, we tried 10 different types of products. I worked as a sustainability manager at the University of St Andrews, and I wanted to know about these products for putting into the university. So we had a thermofleece and warm cell, which is newspaper that's been shredded and is a work of the devil. I wouldn't go anywhere near it again. Here, pit and wean, we installed triple glazing, spent a lot of money, high exposure house. We needed it to minimize the drafts. And in calendar, I'm just very cheaply installing polycarbonate sheets, cut to size, and stuck on with sticky back magnetic strips. Very easy to remove, and that's actually made quite a difference here. So that was a very simple thing to do. So we then improved the heating system in pit and wean. We had the solar thermal panels on the roof, a heat pump. We were looking at air source or ground source, and then solar PV, which lower the carbon but doesn't lower the heating in the house. So solar thermal, that was the solar thermal panel, which we put on fairly early on in pit and wean, and it achieved 75% of our hot water demand throughout the year. It is really quite effective. Even in winter, it was bringing the tank temperature up from 10 degrees to 25 degrees, so that the other heating systems didn't have so much work to do. So that was good. And then we installed a 7 kilowatt heat pump and oversized radiators. At low temperatures, the radiators need to be about 3 times the size. So we put a lot more radiators in. We were worried about it being overpowering, but actually you don't notice them after a while. And you get a very low temperature, cozy heat. It's really nice. We did look at a ground source heat pump, but it would be significantly more expensive to do that, to drill the boreholes, and the efficiencies wouldn't have made a payback for it. So we put the solar PV on, generating electricity for free, and then a small battery system in our loft, which stores the energy when the sun was not shining, as that was the strategy for that house, so we could then use it during the day. For Calendar House, we've got a larger roof, and so we've installed 5 kilowatts of solar PV panels and 13.5 kilowatt hour battery, which is significantly larger than the last one. This one, here we are getting we're paying 8p a kilowatt hour at night, and we actually get 15p per kilowatt hour to export our solar. So we're using the battery to charge at the night rate and run our house, run the heat pump when it's on, and the solar goes straight to export during the day or tops up on the heat pump. So the system will also power the house in an electricity cut. So we have a lot of resilience now. Being a rural house, we do get power cuts from seconds through to several hours, a couple of days, and we'll be able to run the house during the power cut. And the future for ventilation, I'm going to install this mechanical ventilation heat recovery system. It's going to go in the garage. It's all being designed out. When the heat pump's installed and everything's back to normal, I'll then go and put that in the summer. We're going to have to clear all the loft insulation to do it properly because we want to air tightness the loft. So we're going to wait till it's a bit warmer before we move that, and then we'll put all the insulation back in our loft. So what were our challenges here? So again, we're trying to prepare our house for climate change. So this is the roof going on to our bungalow, and we were looking at our rainwater soakaways, which didn't cope during deluges. So I've redug out all of the pipes and relayed the pipes to make sure that they're all running freely and that the water can get away from the house. And then on the front of the house, we'll be storing that water remotely for use in the garden. But we just needed to make sure that, again, the house has got big overhangs, a lot of ventilation in the loft there. Challenges here, from going from natural gas to a country house where we're working on LPG with a big tank, 2,000 litre tank. And it was sort of weird trying to work out our heat consumption. I'm used to having lots of meters, and here you're just photographing a dial and working out that 50% of a tank is about 7,000 kilowatt hours stored in it, and then you could see it go down. But for us, once we've got the heat pump in, we're going to get the tank out, and they will only remove it if it's under 5% full. So we've been eking out the gas at the moment till the installers arrive, and it's now virtually empty. So the boiler went out on Monday, but that coordination bit was something that hit me, and I hadn't been aware of that before. In this house, we want to only use natural insulation. We don't want to use kingspan or polystyrene. So we're insulating the walls, and that's a photo of the wall plasterboard being removed, showing the timber frame construction with a brick outer. But we need a detailed condensation risk before super insulating the walls, because we don't want to insulate the walls, close it all up and think we've done a good job, and actually be rotting our timbers. So we're playing cautious. We're waiting for the experts to give us the go ahead on that. But in the meantime, we're maximising the loft insulation and the underfloor insulation. So as soon as the guys are finished with the heat pump, we'll be under the floors working on that. As a comparison between the two houses, the pit and room house was 107 square meters. The bungalow's bigger. The pit wing was 1950s brick and cavity. The 60s was a cedar-clad frame, which then had an external brick put on it. We're very wooded and sheltered here, very noticeable in the storms that the wind passes over, whereas in Pit and Weem, it's very, very exposed. We had mild winters in Pit and Weem, very rarely got frost, whereas we get a lot of frost here in Callander, and 3 times the rainfall. So we've got a weather station up monitoring that, and it's much, much wetter here. So we took Pit and Weem from an EPC of E to an EPC of A, and we've bought a house with an EPC of F, and we're going to bring it up to as high as we can. I'm not too sure what it will be. We're saving the planet one house at a time. And in terms of heating loads, we halved the heating load. This house has higher heating load, and we're not too sure what we're going to get it down to, but we'll be using the heat pump. The annual bills in Pit and Weem were only 450 in the last year we were there, so that's nice news. I like that. And we'll be working on getting our bills down on here. Most importantly, I monitored carbon emissions, and so the direct carbon emissions of the house in Pit and Weem were 2.5 tons to begin with, because it was on natural gas, and we got that down to 0.5 ton per year for which was really, really good for its operation. And the Callander house is 4.8 tons because LPG's got a higher carbon emissions, and it was using more gas and a more inefficient boiler. And the measures we've put in so far, once we've got the heat pump working and the solar PV, bring it down to 1.4 tons without doing anything to the walls or the ceiling. When we've done that insulation, we can easily bring it down to below 1 ton of carbon. So that's we're over a quarter of the energy we had, carbon emissions we had before. What we're aiming for is a cozy house that with low bills that we don't have to worry about, and we don't have to worry about storms. We don't have to worry about rain. It's all going to work. So there's a bit of disruption at the moment, which we're very, very happy to put up with. We had neighbours in Pit and Weem who had spent a similar amount of money on putting a new kitchen in, and they came into our house for cooking for 2 weeks because they couldn't get into their house. And I'm feeling happy that they were spending the money and having the disruption, but we're going to have a nice, warm, cozy house at the end of it. So it's interesting what your motivation is. Do you want a cozy house? Do you want to adapt to climate change? Do you want to minimize your annual carbon? Or do you just want lower bills? Because a natural gas combi boiler with large radiators will actually reduce your bills, but it won't reduce your carbon. Then there's the supply chain ethics. Did we want a Tesla battery? No. We were offered one, but we went to a different company. And also we want to support as many of the local contractors as we possibly can. Looking at the embodied carbon of an upgrade, we did think about knocking the bungalow down, building a passive house, and actually, no, that's a very high embodied carbon solution. We want to live with what we got. And do you want to be self-sufficiency and off-grid, which is what we're aiming for here as much as possible. So that gives things that you might be wanting to think about for any of your upgrades that you're doing. So thank you very much. That's a photograph not of our area, but a Pit and Weem, and a link to the blog I did of the last house. I'm preparing a blog for this house, and with FEL doing a video blog as well. So thank you very much indeed.
Thank you. That's amazing. Thank you so much for putting all of that information into that presentation as well, David. I think so many things there that, again, we could take one element of your retrofitting journey and probably talk for an hour about. So thank you, and such a huge amount of work that you've done. We're looking forward to capturing your story with your new home. Very much so. Just a quick reminder to people, if you have questions, pop them in the chat. While we're now going to move on to Claire and listen to Claire from Hoose Limited. If you're ready, Claire?
Yep, I'll just find my notes. Is that okay?
I can't see your screen yet if you are sharing.
Sorry, I am, but check, sorry about that. Sorry, I have a circle of doom here.
You should refer it to Isabella for any tech support advice. Yes.
Is that it? Is that yes? No, no.
I can see your presentation yet. Perhaps is there a presenting mode in that
It's
section?
Yep. No, it doesn't seem to be doing it. It's circling every time I try and do that. Shall I just go ahead and I can give you the? Is that okay? Because I know I'm very aware of
I don't know if
time.
No worries. Yeah, go for it.
So anyway, I'm part of. My name's Clare Trodden. I'm part of Hoose, which is a relatively new company. And I hope hopefully I haven't angled this at too low a pitch. I knew the others would be pretty technical, and normally our presentations would be fairly technical as well. But I wanted to talk more about not just the company, but what we're aiming to do, because I think it fits very well with the whole theme of what Tom is doing, but also what David's doing, actually, very, very impressively. So Hoose is largely primarily set up for sustainable construction for ultra efficient, healthy homes. And our logo is the tree of life, which illustrates how all lives are linked and connections between people and processes and the impact on each other. It was a vision to create a new way of building and living and working and retrofitting. So it wasn't just, I will come to the retrofitting in a moment, but this was what Hoose was about initially, was to build sustainable homes that were good for those living in them, those working on them, and also for the planet. Big aims were to quietly help revolutionise the construction industry, which is not a particularly friendly place often. And this is not to diss all companies, but some of the larger movers and shakers maybe would tend to build the lowest levels that are possible. So we wanted. We soon expanded because everyone within the company had a lot of experience with retrofitting, all of us personally and professionally. So it might sound we wanted to create a slightly different way of working, as I said, like a win-win-win, so that everyone who's involved is kept up to date. They know what's happening, whether they're clients or people who are contractors or whoever it is, anyone that's involved in it. And with the sustainable underpinning strongly at the start of the base of the company. So it does sound like a bit of a utopian fantasy, particularly in the construction industry. And it was a dream, and it became a reality when two of the founders met at a network, something like this actually, but in person, and shared their vision. So it is not pie in the sky. It's based on many decades of experience, academic research, and knowledge in construction, design, and conservation. And there is a core of the original, almost the original founders was an architect, an academic who's teaching in the School of Architecture in Liverpool, and a builder. Coming together to share knowledge to improve ways of working and living. We also have in-house designers, engineers, fabrication assembly teams, all that you might expect. And it's everyone. We often, many of you will already have done retrofitting in your own homes or be about to do it. It can be quite a difficult and lonely process as you go from one person to the other. So we are under one umbrella, and people would deal with one person largely. It's part of the new build aspect was to create a mobile plan, a prefabricated homes that could be built on almost any site, but with minimal impact. In fact, positive impact if possible, low maintenance, low energy, low carbon, all of these things. But as I said, so all of these things, we've never stopped retrofitting since Hoose was set up. Retrofitting is obviously important, as Tom said. It's the houses that are here. It's obviously much better for the planet if we can work with them and make sure that they work as efficiently as any new eco house would do. But we want to apply the same values and expertise to this. Relationships and collaboration are a key part of how we hope to work. And I'm not talking just about our company. I don't want this to sound like an advertising thing, because it's something that we hope to spread. So it's from treating each other with respect within the company, whoever is working with you, but also spreading that out. So clients, suppliers, the whole supply chain, we check into to make sure it's ethical, responsible, sustainable as much as is possible. And we also want to have a lifelong relationship with clients, so that it's as positive an experience as possible. Because you will know if you've done any of it, it is a fairly isolating, and it can be like a bit of a money pit. So we, as a team, we are always learning. We think it's important to give back and share knowledge. We've got relationships with local schools and universities in Scotland, England, and abroad. And we also want to be able to share the expertise that the team have gained over the many decades, almost a century actually, between the three, the architect, the builder, and the academic, and to share how this could be done so that other companies, so it's not just, we don't want to just be pulling up, we want the whole industry to have access to that. So sharing knowledge and giving back, we think, is very, very important. And wherever there's an opportunity to do this, we will do it. We also want to upskill people who work with us, and that might be community projects, so it might be people in the community actually getting involved, either simply in a learning capacity, or it depends what skills they've got, whether they actually might work on some of the projects and perhaps get upskilled. So it's as we know, as has been clearly laid out, it's not a panacea of retrofitting, and what I'm saying is absolutely not a panacea. It's a tough process. I mean, what any good retrofitter would do would be to spend time with clients, because we understand how challenging it is. As I say, we've all done it. But we're even thinking about, so what are your, as David said, what is it you want from your retrofit? And when you are speaking to your builder or anyone else involved in your process that you go to, it's making sure that they take time to listen to you. Also to see how you actually live, because we often think we want certain things. Is it money? Is it to save money? Is it to save the planet? Is it to live healthier? Is it to cut down your bills? All of these different things, and that's what should be included. But also, so where you'll cook, where you'll go to the loo, if you don't have kind neighbours like David, what are you going to? How long is it going to take? How long do you have? Who are who's living in your house? It's important to take the human aspect into that. So occasionally clients we've had, there's someone living in the house who's dementia, there are neurodiverse residents. how do you focus on making it as bearable as possible for them as well as everyone else, and plan the way ahead. So I think that's when, for you who are, I think quite a lot of people who are either thinking of retrofitting, who are actually doing it just now, is very, very important. Now, I was going to talk about the problems, but these have all largely been covered in more detail by Tom and David, particularly David, illustrating the problems that he's felt and dealt with. I would definitely stress, so that one size doesn't fit all. Heat pumps are buzzwords, and they're fabulous things as are solar panels. But older buildings, the issues are so complex that sometimes we've all experienced things where we've had things done in the past, and at the time that might have been absolutely cutting edge, but they don't actually work anymore. In fact, have maybe caused some problems. For instance, membranes fitted to keep out moisture, if not fitted correctly, will actually bring water into your home. And there's so many different types of materials involved, and the different upgrades. So you could have one wall might have bricks, concrete blocks, lime, and many other materials. So it's like a jigsaw and a balance and almost an equation of dealing with all of these different materials, seeing how they interact, and old and new interacting together. It's not always the best thing. So I mean, in some cases, and I'm not saying it's a magic wand or it's as simple as this, but in some cases, it can be as simple as replacing your guttering and properly ventilating a damp home can be the most cost-effective and straightforward solution. So even in insulation, if you have fabulous big thick walls, insulation might not make a huge amount of difference. And solar panels are fabulous. I mean, we have a company that do solar panels, but it's not for everyone. And it depends how much ground you've got about your heat pumps. I mean, they're evolving and they're getting much more efficient, but finding the people to fit them, engineers there are many, many boiler engineers, of course, in this country, not quite enough for the expertise maybe that's needed for the different types of heat pumps, especially as the heat pumps kind of move on and get better. Some of the projects that we've done, there was one that wasn't us, but a new school built, a Scottish school, and they used cheap lightweight insulation, which met one need. So it ticked a box because it was fairly easy to use. It wasn't too expensive, so that was ticked. And great on paper, but cost-wise, it didn't work out to be so good, because the overheating that meant they had high costs to try and bring down the temperature within the building. Whereas more, when I say natural, more traditional, old-fashioned maybe, but now very modern types of materials, hemp, sisal, wool, are more mass. So they help to regulate the temperature of your building. So although, like the printer analogy that I use, when you don't have much money, a £60 printer sounds like a great deal. And it is a great deal when you need it right now. But it tends to cost you more in cartridges, they don't work so quickly, and you're just really kicking the problem down the road. And it's a hard fact of life, particularly if you're facing a retrofit, that you have to look at the whole issue. You have to look at the where you are, the surrounds of your home, all the materials within it, to see what you actually can do and can afford, and what's going to work. So some of our projects, we've done a wide range from a 100 square metre cottage in Crieff, near Crieff. We've done to the other side, which is in just outside Stirling, an entire retrofit of a 600 square metre steadings. And that's been a very big project. I mean, that we also included, we got caught up in bats nesting. So it's a maternity wing in the roof, the old roof. So that's all had to be dealt with and built in, so that there'll be some function for the bats to come back, so that they can still nest and do their fabulous bat business, while still repairing the whole roof, renewing the roof. That particular retrofit also exposed a lot of things that had been done in the past not so well. So anyway, I'll see the time. I'm going to be very cognizant of the time. There's also a commercial project, which is an old and new thing, and trying to find the best ways. They want to keep running, obviously, it's in hospitality, to make sure that it's possible. But I'll go back to what is the most important thing, I think, for you is for someone to spend time with you, to see what's needed and wanted, and see what the restraints are in your budget, and being as realistic as you can, because there are things that will make a difference within any budget. But for instance, any decent contractor, builder, architect, and we would certainly know this, if you had a leaky roof and wanted a new kitchen, they wouldn't do it. They wouldn't give you a new kitchen unless the fabric of your building is secure. So also we'd be looking ahead to the running costs of your house. As I said, we've got some, in that bigger retrofit, we're doing some research and an academic programme. We've got a partner there to look at, there are sensors going in, and we'll have sensors, video imagery and videos, so that we'll have the data for how of these different types of fabrics work. And also we will keep these sensors in so that we can look ahead to before there are problems in old buildings, before the damp or anything that happens gets to a certain stage, we can move in, and hopefully deal with that quite quickly, so that in the same way as a new build might be low maintenance and cheaper builds, same things can apply with the underpinning of it's been better for the sort of environment. But I would say it's not an easy fix. You've got to be realistic. There are appropriate solutions. There is a great, I mean, I know sometimes if you're in a home that's needing them, it's a big problem. So anyway, I will stop now. I would love to continue this, and I would like to thank you all for your time, and all the best with the projects that you're undertaking, if you are undertaking projects at the minute.
Thank you, Claire.
Thanks.
Thank you. And thank you everyone for speaking today, because I think all three really complement each other and show different examples of how support is there before you have to, hopefully you have time to plan these retrofitting journeys. But as you highlighted, sometimes it has to be quite responsive as well. So in the last couple of minutes, does anyone have any questions for our speakers? I've got a nice comment from Tom, if it's okay to read out this one. The one thing I love about David's Calendar House case study is it demonstrates so clearly that the single biggest carbon emissions reduction action you can take in your home is to stop burning gas. So therefore, if carbon emissions reductions are a priority for you, you should give serious consideration to taking a similar path as David and get a heat pump installed ASAP. So thank you for that comment.
That's a big if. Because if something else is what you're trying to achieve, such as to improve the comfort of your home or something like that, a heat pump may play a role, but there might be other things that is more important for you to tackle first.
Thank you. I did have one question that was linked to any experience using funding. So this was on our Eventbrite. So it was just someone had asked about how to work with Home Energy Scotland grants and loans, given they have existing renewables that require significant upgrades or improvements for their needs. So they've recently purchased a property and want to make it more energy efficient. I don't know if anyone can offer any quick feedback on that.
I'm receiving £11,500 from Scottish Government for doing this work, 9,000 for the heat pump, which actually is not as much as the work costs, but if I needed a new central heating system anyway, so it really helps out, and 2,500 for the solar and battery, which is good to have. So in terms of the overall costs, it helps out, and those grants are available now.
And Tom?
Well, it's a question for Claire. Do you help your customers navigate HES funding?
I don't particularly, but yes, they do. They would help with that. The team would help with that. I know it's a really complex and often difficult issue to see what you can get and where you can get it. But
Yeah, that's right. It's
they're
complex.
well versed on that. Very complex.
And they don't allow third parties like a supplier like yourselves or an advisor like Loco Home to represent households. So you need to navigate it yourself. The best we can do is to offer guidance.
To guide them, and support.
That's right. And there's mention in the chat about establishing a calendar equivalent of a Loco Home, which sounds amazing. This would be incredible, and others in the region. But one of the key things we do is we help navigate that funding for the members.
We would love to have more, and I'll maybe email you separately, maybe both of you. We'd love to kind of share information and maybe it'd be a marvelous thing for us to be able to collaborate in a wider, to meet more people who are doing this. Absolutely, it'd be great.
Thank you, and thank you, Tom, for highlighting that differentiation there. I'm sorry that we've run out of time, but do please stay in touch, and with any follow-up questions, hopefully you've got links to our speakers there today as well, and we'll feed over any resources that we have as well. So this has been our last in the series, but we do hope to continue these with next year's programme from the Climate Action Hub. So again, any feedback, or if you would like the same themes but with more details and different speakers, we can also do that. So any feedback also very welcome. And a huge thanks to everyone for spending your lunchtime with us. Hopefully you have been able to enjoy some lunch, and a huge thanks to our speakers as well. So I hope you enjoy the rest of your day. Do link up with FEL Scotland's membership for, as I say, kind of up-to-date notification of our new events and things happening. And just be mindful, if you're interested, we are doing 2 lunchtime learning sessions the first 2 weeks of April around the community benefits consultation as well. So thank you very much. Another really informative time. So thank you. Stop.